Welcome to Solving Right Triangles. Today's objective is to use trigonometric ratios to find angle measurements in right triangles. So the definition of solving a right triangle is to find all the angle measurements and to find all the side lengths. So in this example right here, we're given two of the side lengths and we know one of the angle measurements was a 90-degree angle. So we can use all that information to help us find out the other measurements of this triangle, that being the side lengths and the angle measurements. So the first thing I want to do is I want to find the angle measurements. So if I want to find the measure of angle A, what I can do is I can use something called an inverse trig ratio. So in order to use an inverse trig ratio, I need to use at least two of the side lengths. So here I have 7.5 and I have 5. So 5 is the opposite side of angle A and 7.5 is the adjacent side. So if I remember my trig values, SOHCAHTOA, this isn't sine or cosine, but since it's the opposite over the adjacent, I know I can figure out that the tangent of A has to equal 5 over 7.5. So once I know that, I can use inverse trigonometry to figure out the measurement of angle A, because that's what I'm looking for. So in order to do that, we have to find the inverse trig function of 5 over 7.5. So we'll plug that into our calculator and we'll get that the measure of angle A, it comes out to be 33.7, so we'll round that up to 34 degrees. And that is our measure of angle A. Now we can find the measure of angle C by taking 90 and subtracting it from 34, which gives us 56 degrees. Alright, so we have figured out two of the side lengths because they were given to us, and we found two angle measurements. So all that's left is this third side length, which is the hypotenuse. Now this is a right triangle, so we can use our Pythagorean theorem to help us find the measurement of AC. So to find this, we are going to do 5 squared plus 7.5 squared equals C squared. So 5 squared plus 7.5 squared gives us 81.25. But as we know, we have to take the square root of that. So that's going to end up with the measure of AC is going to equal about 9. So once again, solving a right triangle means finding all the angle measurements and all the side lengths. We used our inverse trig ratios here to find the measure of angle A. We knew that the sum of a triangle's interior angles have to be 180, so we were able to subtract 90 from 34 to find 56, and then we used the Pythagorean theorem to find the measure of AC. So let's figure out how we use our knowledge to help us find the angle that streets make with a horizontal line. So in this scenario, we're looking at Baldwin Street in New Zealand, which is the steepest street in the world and has a grade of 38%. So we have to find the angle that Baldwin Street makes with the horizontal line. So for this problem, it's going to be helpful to draw this out. And the key information here is going to be this 38%. So what this says is that for every 38 feet that this street increases, it goes 100 feet. So that's where they get the 38% from. So let's draw that out. So we'll draw a triangle, and this isn't drawn to scale, but What this is saying is that for every 38 feet that this street increases in the air, it runs 100 feet. And what they're asking us to find is the angle that Baldwin Street makes with a horizontal line. So this is Baldwin Street right here. This is the steep street. And this is the horizontal line right here. So you want to find the angle, this one right here, that Baldwin Street makes with the horizontal line. So we're going to use our opposite over adjacent once again. So we'll just skip a step and do our inverse tangent of 38 over 100. And that's going to give us the measure of angle A. So we do the measure of angle A is going to be about 21 degrees. So the only difference here really was figuring out what to do with this 38%, but once you figure out that that just means that it goes up 38 feet for every 100 feet that it goes out, you'll be able to use your trig function to figure out what's happening. So another style of problem that you'll see in this section is solving right triangles that are in coordinate planes. Now this can be confusing at the beginning, but once you figure out how to find the side lengths, it doesn't differ very much from the other problem that we did in this video. So the first thing you should do is find the length of each side. So you can count here on the coordinate plane, and from K to L we have 1, 2, 3, 4 spaces. And from K to J we have 1, 2, 3, 4, 5 spaces. Okay, so now that we know those two side lengths, we also know this is a right triangle. Let's find our third side length here, which we can do by using the Pythagorean theorem. So we'll do 4 squared plus 5 squared equals our c squared, which is JL. So we're going to end up with 16 plus 25 equals c squared. And we'll have c squared equals 41. So c is going to equal the square root of 41, and that's a prime number, so we can't do any more with that. So now we need to find our two other angle measurements. So let's find the measure of angle L first. So to find the measure of angle L, we can use 5 over 4, and we could use our hypotenuse, but I've written those there and they're easier to work with. So that once again, that's opposite over adjacent. So opposite over adjacent is the tangent ratio that we want to use. And we're finding the tangent of angle L, which is going to be 5 over 4. So we want to use our inverse trig. So we'll do inverse tangent of 5 over 4. And we'll punch that into our calculator, and we get 51 degrees. Okay, so we could do the inverse trig twice, but let's make our lives easier, and let's just subtract 90 from 51, and that's going to give us 39 degrees. And that's going to be the measure of angle J. All right, so we found our third side length using the Pythagorean theorem. We used our inverse trig function to find the measure of angle L, and then we were able to find the measure of angle J by subtracting 90 from 51. That's going to be the end of our video for today. I hope this was helpful. Thank you and take care.